Now we're going to go the other direction. We have the logarithm expressions being expanded. We need to condense. So with that then, we look and see what we've got here. We've got two logs that between the two of them there is addition. Alright, so that means there's going to be multiplication on the inside of the log, which you can see represented inside here, right, with the dots or just putting the two numbers next to each other. Okay. Now what we have to do now is, if we see a coefficient in front of the log, he needs to be put back into the log. All right. Now this gets a little tricky when okay, I'm going to use a smaller pen here just because there's not a lot of room here. I'm going to put him back, but now when we see this guy is actually 1/2 the log base 6. All right, he's actually 1/2 the log base. When you divide something by 2, you are cutting it in half. All right, so it's like multiplying by 1/2. So that means then that we have the log of 6 raised to the 1/2. We can put that 1/2 back up to the top. Now we already said that a fractional exponent means that you're taking a root. Now if you're taking the second root, that's the square root. Alright, so that's the square root. Alright, so now at this point we have our two expressions. We need to squeeze them together, and because they are logs, we can make this work as follows. Okay? That's it. Nothing else to do. Now you really should put parentheses around this, and we can see this expression right here, 7/5, so that's D. Okay, moving forward then, we're going to do the same thing. This is a little easier because you have both of them, they both have 5. So it looks like we're going to get a 5. 5 goes right to the inside, okay? But because we have subtraction, we're going to put these on top of each other. Okay, it's going to look like that. And where is that? Oh, now these are all multiplications, so that's ridiculous. That would have to be a plus. Okay. Moving forward, same thing, except now you have an ln. Doesn't matter. It has a different base, but the same 3 rules apply. So we're going to get an ln. I keep writing h for ln. I want to abbreviate it. ln, and then 12 to the 4th plus ln 7 squared. All right. We have addition here, so it means the 7 squared, and the 12 to the 4th power can get squeezed in, not by division. Okay, that would be subtraction. Okay, none of this makes sense. None of that makes sense. Well, where'd that come from? It's got to be E. Okay, 46. You got 3 of them. No big deal. Let's just take 2 at a time. These guys have nothing going on with them. Nothing here, so I can actually ln of 2 times 3 plus the ln of 5 squared. I just combine those two and then put that 2 up to the top of 5, that exponent there. This is now ln. Oh. Why am I writing h for every single ln? This is crazy. How many times have I squared? 1, 2, 3, 4 times. Okay. ln of 6 plus the ln of 5 squared, which is 25. But if you look at your choices, it looks like I see 5 squared in a couple cases. So we're going to bring these two together by multiplication, and so that's what we see here. So even though we have 3 of them here, it looks like these two are so easy to combine, they went ahead and did it. 25 times 6 is, I mean, you could have figured that out too, but it looks like they just kept it right here. All right. Okay, so now we're going to solve these. Alright, now solving these equations, looks like we got 6. Now there's really 2 situations. You have a log equaling a log like that, okay? And then when that happens, you can just cross them out as long as they have the same base, and they will on this test. Sometimes though you have more than one log. Okay? And when that happens, these guys have to be condensed in order to solve, and then you will cross off. Or the third case is when you have just one log, and in that you will have to do the loop in order to solve for it. Okay? So there's only 3 situations. One in which there's 2 logs on both sides, instantly cross them off, easy peasy. This, squeeze them together, then cross off. All right, and that's either division or multiplication, depends on how they're expanded. And then here is when you just have 1 log, and then you have to do the loop. All right, those are the only 3 situations that you're going to encounter. Now, this is circumstance number 1. Okay, you have a log base 9 equaling this value equals the log base 9 equaling that value. Since they have the same base, cross them off. So what that means is P equals 3P minus 6. End of story. I'm going to subtract 3P from both sides. Negative 2P equals negative 6, so the answer is 3. And when I plug 3 back in, notice that that's a positive 3, no problem. Positive 3, that's 9 minus 6, that's a positive number. So there's no extraneous solutions there. So the answer is good. We're good. 48, log on both sides. Bam, bam, same base. So now we set these equal to each other. And this guy's going to be a little different because he's going to be like an equation that we solved way back in November when we were doing quadratics. All right, now quadratics, now the reason why I know it's a quadratic is because I see a v squared. So if you remember, we should always kind of expect 2 answers. All right, and we see that there's 3 pairs of answers here, but maybe there's extraneous solutions here that we need to be looking out for. So whenever you solve a quadratic, you have to set it equal to 0. So these guys have to move over here because we always want to keep this coefficient in front of v squared. All right, the quadratic term, we always want to put we always want to keep that 1, a positive 1, so that we can use the x method. Now when I dial these guys to 0, I'm going to have to add an 18v, but he's not adding to any of these. He's just going to be a positive 18v because these are unlike terms, so he's going to stay right there. But this 2, I need to subtract, so he is going to drop to 81. Okay? Now I've dialed it all to 0, and I have factors of 81 that add up to 18, and that's going to be 9 and 9. So it means that my parentheses look like this. X plus 9 equals 0. So what value gives me 0? Looks like I only got one answer here. This is a multiplicity of 2, by the way. So the root is negative 9 with a multiplicity of 2. And plugging it in here, we get a positive plus a positive. Negative 9, positive plus positive. So I'm all set, not extraneous solution. All right. Okay, now I have situation 2, where I have 2 logs on one side that need to be squeezed together so I can get rid of and make it a situation 1. Okay, so I'm going to go ahead and do a log, squeeze them together, 4x squared over 4. All right, because the 4 goes under the 4x squared because it's subtraction. So now that equals the log of 25. Now we're back to situation 1. Cross them off. Now we're back to here, and this is Algebra 1 skills right here. Okay, got to remember how to do this. 4's cancel out, right? No big deal. X squared equals 25. Well, take the square root of both sides, and you get x equals positive and negative 5. But am I going to get a negative answer here? Nope. If it was negative, then it would become positive again. So I'm all set. So it looks like we have positive and negative 5 is C. Moving along, this looks just like the same problem. I'm going to squeeze them together again. 2x squared over 2 equals the log of 16. Okay, look here, subtraction, so these guys can unite with division. It looks like same situation. So I can undo these logs and get x squared equals 16, and I get a 4 and negative 4, and there are no extraneous solutions because negative 4 will be squared here and become positive, so I don't have to worry about it. Okay, now we have this right here. Looks like it's the same kind of situation. Do I have anything that's... No. Well, these are kind of repetitive. So here we are... No, here's a little different. This is going to be multiplied together. So notice that the ln's, you're not doing much with the logs other than using properties of them and then getting rid of them. You know, it's not like you're not taking the log or taking the ln of both sides. That's already happened. All right. Okay, so we can squeeze these together. There we go. Instead, I'll just write it in cursive. We can squeeze them together with multiplication. Then it will equal the ln of 32. Now I can cross it off. Ln's are gone, and I get that x squared plus 4x equals 32. This is a typical quadratic. You've probably solved it. We've done so many of these. You have probably already solved this before. We got to dial it to 0, so we move that 32 over here. And then we'll do the x method, and we get the 8 times 4. 8 times 4. Okay, so it looks like positive 8, negative 4. Okay, positive 8, negative 4. So that means positive 8, negative 4 equals 0. So I need a negative 8 and a positive 4. But let's make sure what happens here. Notice that when I put in negative 8 right here, that would be the ln of negative 8. Alright, and I just want to show you why you cannot have that answer, because the ln of negative 8 is non-real. Okay, it's a complex number. So therefore, is it even, no, I don't, it's undefined. No, it's undefined. So that can't happen. So here we have an extraneous solution. Alright, so we cannot have negative 8. We can only have a positive 4. When I plug 4 in, no big deal. Plug 4 in, 4 plus 4 is a positive 8, so that's okay. Alright, so our final answer is A. Alright, 52. Alright, so we're going to squeeze these guys together to get an x squared minus 6 over 5 equals the ln of 71. Alright, because this term here gets divided by the 5 because of the third rule, the quotient, no, second rule, quotient rule. So now I can cross them off, and I'm going to get x squared minus 6 over 5 equals 71. Now, you have to multiply both sides by 5 before you can solve this quadratic. Okay, this entire side is being divided by 5, so make this side multiplied by 5, and you've evened the playing field here. Equals, let's see, we got 5 and then 30, that's 355. So now what I'm going to do is I'm going to not dial this guy to 0 because there's no middle term. This is easier to do when you don't have a middle term. I'm going to add 6 to both sides, and I'm going to get 361. So that means x squared equals 361. Now I know that 361 I think is 19 squared. It is 19 squared. So that means I have plus and minus 19. Okay, it's a little faster when you don't have a middle term because there's no target for you to aim for with the x method. Okay, this guy had a middle term of 4x, so you needed a target. This guy doesn't have a target, so you can literally just not set it equal to 0, put it over and take a square root. It's called the square root method of solving quadratics. Okay, so if I put in a negative number here, no problem, and there's no other input for it, so it looks like C is the answer.